Hello? Hey, can you hear me?
Yeah.
That's good. I know it's been a while, but were you able to study the worksheets?
Yeah.
Okay, that's good. Let me just go to the one. So here you go. Did you guys cover like all the other things? Like what was the end like for the exam? Because I know there was the sum differences, which I think you're really good at already. And then the double angle, right? The double angle. And can you see my screen by chance?
Yeah.
Okay, that's good. Okay, so did you guys cover what was the other one? There's the half angle one. Let's just go back to
Um, can we do some of those because they still kind of
Okay.
confuse me.
Which one, the half or the double angle?
The half.
Okay.
No, not the half. I mean the double.
Oh, the double angle, yeah. The half angle I know we covered. So let's actually go over this. What I have. This is your worksheet, yeah?
Uh-huh.
So like there's the one thing I know that that's like really good is like solving the equation for trig. I know that one's not bad, but do you remember, so we'll cover this guy, and then do you remember it's actually this guy right here? The one where, and I wanted to cover this really intensely because you have to remember that's the triangle, the Pythagorean triangles. Like you're given this guy, a particular sign, but you actually have to solve for something else, a double angle.
Mm-hmm.
So we'll go over that. Let's I guess we'll go over them one by one. So for this one, we'll start out basic fundamentals. So for the half angle or the double angle, when you have like the very first one here, sine 2 theta equals 2 sine theta cosine, right? That's the very first one. You can just apply.
Yeah, that one.
You can just apply this guy,
the quiz. Yeah, this was a quiz. This was actually like really easy.
Okay. Yeah, I know. But then just applying it like the basic view, because then we're gonna try to apply it for this guy. So like it's kind of similar to what you did with the half angle one, right? Like it's just pretty much looking at what you have here and then matching it. So this guy had 15. So wherever the theta is, you just times it by the 2 inside the sign, because that's where it equals identity, right? So like this theta, which is what you have here, 15, you just times it by this guy. So sine 30. And then you already know how to do that, right?
Yeah.
Yeah. So that one's simple. And then let's look at this one. For the tan one, I would just try to like, you guys are providing?
Yeah. I understand everything that was on this worksheet.
Which worksheet are you talking about then?
The one that you're on right now.
Okay. Did you guys do number 5?
Yeah.
Okay.
It was for a grade.
Okay. But do you know how to do it fully? Because I think this is gonna be in the exam.
Yeah. This one I actually thought was like pretty easy.
Okay. Just remember to know your Pythagorean triples though.
Yeah, it's okay. The thing is, we took an assessment today. We worked in groups, so we got 100. But some of the problems were like kind of iffy.
Do you have that? Do you have that like worksheet?
Somewhere? I don't, but I do have some of like the questions that I did.
Okay.
So like I did one. Sine plus cosine equals square root of 2.
Sine of theta plus cosine of theta.
Theta equals square root of 2.
And you have to solve for. Well, what do you do? What do you do with this one?
You have to solve for like where it would work on the circles.
Oh, so this is it's pretty much solving the theta, right? For the theta.
Yeah.
Okay, so it's kind of like the solve trig equation. Okay, solve trig equation. It's not that bad. Let's actually do that one. This one, if you square it, it's sine theta plus cosine theta. So for this one, what did you end up doing? I would think you have to square this guy.
Yeah, I squared both sides, and then you get like sine squared plus cosine squared plus 2 sine cosine,
and sine squared plus cosine squared is 1. So then I get 1, and you can switch 2 sine theta cosine theta into sine 2 theta.
Yep.
So I get 1 plus sine 2 theta equals 2, and then I minus the 1, so I got sine 2 theta equals 1. And then
Good, yeah. And then?
Yeah, and then I did the sine inverse of 1 equals 2 theta, and you get pi over 4, and
Okay. And you just divide it. Actually,
yeah.
like the sine inverse, is this 0 to 2 pi? 0 to 2 pi? Let me see.
Yes.
I think it's 0. Usually it's 0 to 2 pi for the most part.
Except if it's like a half angle. Or no, I think you have to make it out of 4 if it's 2 theta. 4 pi.
You said sine inverse of 1. Sine inverse of 1 is pi over 2, pi over 4. I thought it was pi over 2.
Oh, it is pi over 2, and I divided it by 2. That's how I got pi over 4. Never mind.
Okay, pi over 2. Okay. And then I think that's good. And then so pi equals pi over 4.
Yeah.
That's what you got. Okay. Yeah, that works.
But
the other one is okay.
Those type of problems are just iffy. Okay, another one that I saw.
Okay, let's actually go back to this. So like,
Okay.
what part of this is like pretty iffy or like pretty complicated?
Not okay. So we do have reference angles that we talk about, and okay. Also, if we go around the thing multiple times, that confuses me. Like if it's out of 4 pi, you have to. So you add 2 pi to.
Oh, I see. So like if you did like if this is 0 to 4 pi,
Yeah.
like theta is from 0 to 4 pi. Yeah, like if you did like, because if this is from 0 to 2 pi,
Mm-hmm.
you just add 2 pi to it, right?
So how would I add 2 pi? So I would add like
plus this guy 2
pi
pi,
over 4.
2 pi n, and then n. Just do this. Like you don't actually have to. You just add 2 pi like that. And
Well,
it could be.
We actually have to write it out.
Oh, you actually have to write the final number.
Yeah. So would it be? So would you add 8 pi over 4? Is that how you did it?
Yeah, that's this is just basic. Let me see. So when you did this by 4, right? Times 4, that'd be 8. Like this guy, right? Right?
Mm-hmm.
Isn't it?
Mm-hmm.
Isn't that the one?
Yeah. So that's how you did it. I just want to make sure because like I wasn't sure.
Yeah. That's the way you do it. Or if it's like a pi, if it's like from that, you just add like pi over or 4 pi over 4. Make sure these are equal. That's all you have to do. Make sure those are equal, and then just do the arithmetic.
Okay, wait. How do you make sure that it's right?
Okay, how do you make sure it's right? Okay, so let's actually do like a bunch of that here. So when you did like pi plus pi over 3, what is this? So let's do. So what is pi in terms of 3? So it's over 3. It's over 3, right?
Yeah.
And then you just do this, right?
Yeah, but I mean when it's right on the circle.
Right on the circle.
Like if
what
we
does that
get
mean?
like okay, so we can get multiple solutions
Okay.
to it, but not all of them are correct, and I just don't know how you're supposed to plug it in to make sure that it is right. Okay, for example.
Okay, I think I know what you're talking about. So like what I would do if it's like all the way to 4 pi or like it's like 8 pi,
Yeah.
you just add an n here. So if the answer, this should work for like 0 to 2 pi is just n equals 1, yeah? And another solution for this would be n equals 2. So the first solution would be pi over 4 plus 2 pi. That's the first one. If it's all the way to like 4 pi, this is only 2 pi. This is from 4 pi. You can equate them. Whatever the solution that it's given to you, you can just equate it. And is it matching? Is it matching this guy? You could just add an n here, that's why. I think that's what you're talking about, right? I think that's what, because like you can stretch the solution by 2 pi by just multiplying it by a number that will reach like 4 pi the range to like 8 pi, yeah.
Mm-hmm.
And then like if the solution that you're trying to match this with doesn't equate to this or this, then it's not a solution.
Wait, what? How does it what? I'm confused. Wait, why is pi over 4 plus 4 pi? How does that make it on the circle? I'm confused.
So
how does that
like
prove that it's right?
So like the answer to this, if you were to like, for example, what is it for this guy right here? If the answer that you got was like pi over 4, yeah,
Mm-hmm.
that will only work if it's like within. I think there's another, if you add 2 pi to this, because like this is only from 0 to 2 pi. So this one right here is from 0 to 2 pi. So this pi over 4. But what if this range got extended to like 0 to like 4 pi? Yeah.
Mm-hmm.
And it's still going to be on the circle. You're just going to it twice. You're going to the circle twice, right?
Yeah.
But it's just another. What I would probably do is minus like it's the same thing as making like 560, anything that's greater than 360, minus 360 to it, and see if you can get that same angle. If that makes sense, like you can get like maybe like 2 right here, and then the other solution that matches this by going to the circle twice would be like this added by that guy. You're still gonna end up in the same place, yeah. When you revolve this twice, you're in this circle. You were here right in the beginning. This is like you, and then you went all the way around. That's 2 pi, yeah. You went all the way around again. That's 4 pi, isn't it?
Mm-hmm.
You're still gonna be in the same place, right? That's why when you add 2 pi, a factor of 2 pi, that's still gonna be. It's even if the number itself doesn't look like it's an answer. When you add 2 pi to it in Trig, it's you're still in the same place. You're just going in the circle many times.
Okay.
If I can see like that problem, that would be great. do you think you can like take a picture and send it?
Yeah, it is a picture. I have like a picture. Okay, it's like the one. Okay, and then I have like one that we did in groups. So I have like the type of questions.
Okay, try to like I guess tell me the question and maybe if you can send it, that'd be good.
I can just text you it, right? Does it send? Okay.
Let me see. Yeah, just text it to me. Let me see. Okay. So what's the problem? What problem is this?
That we just did?
Yeah, that one that you got.
It's the bottom one.
Okay, I just got it. The 24? Is it 24?
No, it's the 28th that we did. But the 28th, that one is wrong. That answer's wrong. I know what it was after, but someone kept telling me that it was 5 pi over 4. So I was like, okay, fine. But then we checked it and it wasn't.
5 pi over 4 is the. So what is the answer? What is the answer? I mean, I can just figure it out. But...
Oh, it's pi over 4.
Oh, the one that you just told me, yeah.
Yeah.
Okay. So what I would say, let me think. So they're giving you 3 pi over 4, 5 pi over 4, 7 pi over 4. And then if it's pi over 4, and you added pi. So it's not, if you add 2 pi, if you add 2 pi to this guy, that would be the other solution. So that's 8 pi.
Yeah, that's one. That was if it was negative, like if it was including positive and negative. All those solutions.
If it's positive or negative, but if it's only positive, you add 2 pi.
Yeah, that's what I was saying. That's why like it had the pi over 2, pi over 4, 2 pi over 4. That was if it had like positive and negative.
Okay, but do you understand that? I think that's what I don't see where the range is, but are these like the range? Is it up to what, 4 pi or?
Yeah, it's out of 4 pi. If it's a double angle, then it's out of 4 pi.
Yeah, that's like one of those rules things, like a double angle. So for all this, so it's gonna be instead of like so for 28, you would just add 2 pi or 4 pi if it's like positive. If that makes sense. If it's like negative, you add pi.
Yeah.
Okay.
The thing I'm confused about is reference angles. So
reference angles. Okay.
Yeah, we have to use that if it's negative. Honestly, I have no idea. I have no idea.
Reference
We didn't even
angles
do negative
meaning
one.
negative 1 would be pi. That's your reference angle. 2 pi would be the positive. Like that's
No,
the
we would have to find the reference angle, and then we have to do 2 pi minus it and 2 pi or 2 pi plus it.
Yeah, that's what I'm saying. That either the angle itself that you solve, you solve for this guy, right? And this is the within the whatever you solved it for, but you add like an n to it, which is like going to be a positive. And then if you want to make it both positive and negative, you add multiples of pi. You add multiples of pi, and then the solution is going to be just when n equals 0, 1, 2, 3, whatever, up to like 4.
Well, no, it's the one that we do if it'll be like decimal.
Which one is that one?
I don't know if there's like a problem where it's negative.
Because I know I looked at like some of the worksheets she told you or she showed, and then like there's one where like there are decimals, but then she wants you to use a calculator. Is that the one?
Yeah.
But you have to use a calculator. You can use a calculator, right?
Yeah, I think so. I think we can use one, and then you have to like store it, and then.
Oh yeah, make sure you're in radians. Make sure you're in radians.
Yeah.
Okay, I'm just because a lot of people they always like forget that and like, oh snap, the answer's wrong. So okay.
But yeah, can we just do a problem from one of those?
Let me see. Which one is that one? Is that in the one of the ones that you did? That you guys did? I know I have all the worksheets, so oh I see. Well, is it this guy? I mean, this guy is like, you mean this guy right here? I mean, this is like one of those the problems. I think it's like in question day 5 one. The day 5 example of solving trig equations. So like, this is a decimal, right? Sine theta equals a decimal, whatever. I think this is like one of the quiz questions. Like for your calculator, I would just sine inverse this. And then exactly what I'm writing here, sine inverse of the 0.3. Make sure this is in radians. And then you'll get something. So
yeah, but there's times where you have to like you have to do 2 pi minus it.
Oh, I see what you're saying. So like from 0 to 2 pi, it's from 0 to 2 pi. So maybe you have to add like 2 pi. Why you're saying minusing? I think you would have to add to it, isn't it? Because like
it's both. It's either it's
plus or minus 2 pi. Is that what you're saying? Plus or minus 2 pi?
Can you show the worksheet so I can like kind of show you what I mean?
It's not in here. Oh, actually, maybe this one right here. Okay, something like that right here. Okay.
I think yeah, like one of the negative ones.
This guy.
Yeah.
Okay, let's see. Cosine theta, and then if you did that, let me see. So what did your teacher say when you do that? You just do cosine inverse. So that's theta cosine inverse. That's what I would do. Negative 0.9. Arc cosine. And so when you do this one, did you do so for this one? Let's see. So for this one, what I got is in degrees is 154.16 degrees. And then did you just minus 2 pi? Is that what you guys did?
We don't do it in degrees.
Okay. So if you did it in radians, it would be 2.69 rad. And then you would just plus, for this one, you would just plus and 2 pi n. And then same with this one. It'll be 360 though, 360 n. And then that can be like negative. N can be from negative, maybe negative like 2, negative 1, 0, 1, and 2, depending on like if it's from 0 to 2 pi. So for this one, it's 0 to 2 pi. That's why I'm wondering if you guys, why would you minus?
I don't know. We do it in the things. It can't be because nothing can be negative.
Yeah.
I don't.
Because if it's from 0 to 2 pi, I'm thinking you would have to add 2 pi, either 0 for n or 1 for n.
It's like if I don't know how to describe it. Kachi mentioned it, and I was like, I'm confused, but I don't have time to ask because we're taking an assessment.
The one thing I would say, if it's because when it's given you like 0 to 2 pi, I would probably just add 2 pi and 0 or 2 pi, whatever. Like the negative part aspect of it, I don't think that even if the pi right here is negative 2 pi, if it's negative,
wait, I'll send you.
It would make sense.
I'll send you the homework, and you can see like what.
Okay. Let me see. Yeah, these other ones are just solving for pi. We can, like, these ones are not bad as well. The other one that you sent me. Let me look at okay, so I got 3 things. And okay, which one is it for this one? There's like 3 things.
I'm not sure if they have the negative one on this. She just said there'd be a negative one. We can try.
Let me just take a look at this one first. Cosine squared. Okay, that's. But these ones are just solving for the theta, though, right?
Yeah, that's the thing.
So when you solve for the theta, let's just tackle them like one at a time. Okay, so sine. For this guy, it's not really that bad. So what you have to do, you know how to do this one. If you look at this guy, it's not bad, right?
Mm-hmm.
So you're just doing the trig identity here from what we know, and then solve for. So you have cosine here, but you minus it. You always want to like make sure that the right hand side is 0, right?
Mm-hmm.
So you can solve for it, and then like minus cosine, and then so when you do this, 2 sine or cosine theta 2 sine theta minus 1. And then
wait. So when you minus the cosine, it would turn into 0. It wouldn't be a 1.
Which one?
So if you minus if you were to minus the cosine from that side, it would turn into 0. Wouldn't turn into 1.
What is it going to turn into 1?
The cosine on the other side.
No, it would turn into 0. Yeah. Right? This guy.
Which problem are you doing? Are you doing a problem from the homework?
Number 14. I think this is like a problem that you just sent me. Sine 2 theta equals cosine theta.
Oh, yeah. Okay. Yeah, I was just making sure.
When you minus the cosine, it's going to be 0. Every time you do that, that's why you want the right hand side to be 0. So when you do that, this is pretty much algebra, right? You make it, you check each one to make it equal 0, right? Cosine equals 0. Yeah?
Mm-hmm.
And this other one right here is sine minus 1 equals 0. And then you find all the thetas that will make this. It's the same as like any other algebra question, finding the zeros. Find theta that is make this 0. So this one right here is a simple one. So theta, where is cosine equals 0? What theta is that?
Pi over 2.
And then the other one is adding pi to it, right? So 3 pi over 2. And this is from 0 to 2 pi. Yeah, this is from 0 to 2 pi. Okay. So in 0 to 2 pi, it's going to be these guys for cosine. And then for this other one, you could do +1 or sine theta 1 over 2. Where is it positive? So this one, you could either remember it. You already know how to do, like your unit circle. So you could just go off the unit circle. And this is from 0 to 2 pi again. And then if this is from the answer here, if it's from like 0 to like 4 pi, I'll talk about it after. So pi over 6, and then pi over 2, and pi over 6, and then 3 pi over 2. All this is going to be valid by like plus 2 pi n. So in actuality, this is the answer. You add 2 pi n, because like this 2 pi n accounts for like everything. Like not just like 2 pi, it could be 4 pi. But this one, I think you got this one right. Let me, number 12, I think we did, let me see, number 12. Okay, let's do this other one. So this is for your number 12, cosine theta plus sine theta equals 0, yeah? And then like, you just square it. The reason why you're squaring it so that you can get the 2 sine and then the cosine squared plus sine squared. Now that's like the usual. This is the usual way, because then you when you do like the polynomial here, let's just do it like, you know, the way we cosine theta plus sine theta, cosine squared theta, and plus 2. There's 2 sine theta, cosine theta plus sine squared theta equals 0. These two become 1. And this is very similar to the one that you did, right? But then it's not like square root of 2, whatever. So when you mine it, and then this one is just the sine 2 theta equals 0. So that's going to be, let's see. So it's going to be sine 2 theta minus 1. And then sine inverse. So that's going to be, so that's 2 theta. When is it negative 1? So this one, sine inverse negative 1. Let's just go back to arc sine of negative 1. Arc sine of negative 1 is negative pi over 2. Because the arc sine of, yeah, it's negative pi over 2, or 3 pi over 2. So the pi here would be negative pi over 4. Did you get this one correct, or
we can't have negative.
Oh, you guys can't have negative?
No.
Okay. So it would be the other one. So 3 pi over 2. And so 2 pi equals 3 pi over 2, and then pi equals 3 pi over 4. So, and if it's 0 to 4 pi, you just add, so let's say 2 pi and then n, where n equals 1, or 0, 1, and 2. So let's actually do it for n equals 0. You're going to get 3 pi over 4. And n equals 1, you're going to get 3 pi over 4 plus 2 pi, or that's going to be 8 pi over 4. N equals 2 equals 3 pi over 4 plus 4 pi, or 16 pi over 4. I don't know. Is this what you did? Because I'm looking at this. It's you're adding 2 pi, but like you're adding 2 pi, but you got like only 7 pi over 4. You got this first one. Wait. And then the second one is when you add 2 pi to it. Which is going to be 11 pi, yeah? 11 pi over 4. The other one is going to be 19 pi over 4. So you have 3 pi over 4, which is for n equals 0, and then 11 pi over 4 for n equals 1 up to 2 pi, and then 19 pi over 4 when it's like 4 pi, at the 4 pi. What did you get? This is you got the 7 pi over 4. You got 7 pi over 4.
Yeah, because then you just divide it by 2. The bottom would just be out of 8. I mean, out of 4, because you can just.
I did do that one already, but then like that's why I got 3 pi over 4.
You
This is up to 4 pi, right?
The sine of -1 is at 3 pi over 2, right? Yeah. But then you divided. You divided it by 2 before. I divided by 2 after.
When you did the pi, let me see, sine. I see, let me see. So 3 pi plus 2 pi n. Then let's see, when you do that one, so when you do 3 pi over 2 plus 0, 3 pi over 2 plus 2 pi, 3 pi over 2 plus 4 pi. And let's divide the 2 afterwards. So let's see. So 3 pi over 2 times 2. This one is going to be, so it's going to be 4 pi over 2, 7 pi over 2 times 2. And then I see what you're saying. So this one right here is going to be, so 2 to 8, 8 pi over 2. So that's going to be 11 pi over 2 times 2. And then so, because then it's going to be the sine then, right? The sine is the one that you're trying to get, not the one you divide by 2. Okay. So you got 3 pi over 4, 7 pi over 4, and then 11 pi over 4. Did you get the 11 pi over 4 because this is up to 4 pi?
Oh, I don't think I did the 11 pi out of 4. But yeah, I know what you mean.
Okay. Okay. I think that was yeah. If you do that, the trick here is just adding this 2 pi n.
Mm-hmm.
And then making n go up to like until you get the actual pi range. Which is this guy.
Yeah.
All right, let's try to do the other one. The other one.
Can we try number 22?
Send that one. Let me see.
It's cosecant squared.
Cosecant. Okay. Cosecant squared. Okay. Pi.
Theta equals cotangent theta plus 1.
Equals cotangent theta plus 1, but like this. Cosecant squared equals cotangent theta plus 1.
Yeah.
Okay. Yeah. So let's see. So for this one, let me see the identities, because like usually it's the identities that are like. Okay. Cosecant. Yeah, usually when you have these inverse ones, it's a cotangent. I'm almost seeing. I can almost see. Is it cotangent squared or is it not cotangent squared? It's just cotangent regular.
Yeah.
Okay, so it's not that Pythagorean one. I'm almost thinking that maybe you have to square this guy so that you can get a cotangent. But let me see. Or cosecant minus. Is there cosecant minus? Oh, or you could do cosecant squared minus 1 equals cotangent. And then this cosecant squared minus 1 is cotangent squared. Yeah?
Ooh.
You could also do that, and then maybe cotangent squared minus cotangent squared equals 0. I don't know. I'm just trying to play around with it. So then cotangents, that's going to be what? Cotangent minus 1. Maybe that's the one. And then like let's just check that. Let's just check, because like seems like that's the way. Cosecant, and then you make them equal 0. So cosecant squared.
It's also because cosecant squared equals cotangent squared plus 1.
Yeah, that's why.
Yeah.
You could also
So I
do that
understand.
one.
Yeah.
You could also do either that one. There's like within the third one for planning idea, you could do either that or the other guy. You should be able to get the same answer though. You should be able to get the same answer. Let's see. So okay. So let's see if you can do that one and see if you get the same answer. One of the ways that how did you do this one? There's another way that you could do this, but how did you do this one?
Okay, so cosecant squared equals cotangent squared plus 1. So I got cotangent squared plus 1 equals cotangent theta plus 1.
And then what was your final answer first? What was your final theta?
It was pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2.
5 over 4 up to 4 pi? Or 2 pi?
Mm-hmm.
Okay. Let's see. Let's actually do it this way. And the third way where you can do, this way. And then switch it to like sine squared. And then did you get the solution to this? It should be the same if you did it this way or the way you did it. So -1. And if you did, let's see. So if you did like sine squared and then sine, and then 1 over sine squared equals 0. So the numerator is going to be 1 minus cosine sine minus sine squared theta equals 0 over sine squared. But it doesn't matter because then you want it to be equal 0. And so 1 minus cosine. Let's see. So 1 minus cosine and then minus the sine squared is 1 minus cosine squared. And then let's see. So from this, 1 minus cosine plus cosine squared. Let's see, plus, so 1 minus cosine theta, sine theta, 1 minus cosine squared theta, this cancels. And then, let's see. Actually, hold up. So this one should be minus cosine theta minus cosine theta equals 0. So it's 1 minus, oh, I see. So the 1 minus cosine theta sine theta minus 1 plus cosine squared theta, and the 1 cancels out. There you go. 1 minus cosine theta sine theta plus cosine squared theta equals 0. And then you factor out a minus cosine. Okay, good. So from that, minus cosine theta equals 0. And then sine theta minus cosine theta equals 0. And then from this guy, you're gonna get that it's cosine, yeah, pi over 2 minus pi over, and then you got the minus, it doesn't matter. And then 3 pi over 2. And then the sine, whereas sine equals cosine. The other one, let me see, plus, then you can technically do this on tan theta equals 1 cosine, okay. And then so that one would be pi over 4 plus pi, 5 pi over 4. Okay, what did you get again for this?
I got
This is what I got.
pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2.
Okay, that checks off, yeah.
Okay, good.
But you did it in a different way, right?
Yeah.
Yeah, I think this way, I mean, either way, as long as you're mathematically correct with your trig, it should work. Okay, what about another one?
Let me see. Maybe number 18.
Okay, let me
Actually,
see.
no, not that one.
Okay.
Not that one. Number
24.
Sure.
I don't see the stuff in here, so let me just confirm. Is this 2 sine 2 pi?
It's cosine 2 theta plus 5 cosine theta plus 3 equals 0.
Oh, that's a lot of stuff. Say it again.
Cosine 2 theta
Okay.
plus 5 cosine theta plus 3
Plus 3
equals 0.
Oh man. Okay.
Yep.
It definitely likes to give you. Man, yeah. Can you do that? Like when you're doing this, I mean, it's not bad, but like make sure you do it fast. I don't know if you've been doing it the whole week, like these equation ones. But yeah, it does get pretty complex. Let me see. Because then like sometimes when you guess something, you know, like when you find a route and then like, okay, let me actually plug in a substitute there for the trig identity. Sometimes it doesn't get nowhere, you know, which is really, so for example, for this guy, let me just see cosine 2 theta.
Mm.
Let's see if we can make this work. I don't know if cosine theta minus sine squared theta. It's like one of them. Minus 5 cosine plus 3. Yeesh. Let me see. Yeah, I remember. These are pretty brutal because like, if you find like a route, like okay, this looks like it's the right one, then it doesn't get you anywhere. Okay. Wait. Oh, they're both plus. Okay. So cosine 2 theta. Cosine 2 theta. Where are you? Cosine 2 theta. Cosine 2 theta, and then you did. So I guess this might not work, but let's try to do the half angle one. So the cosine 2 theta is square root of, what was the counterpart for this guy? For cosine 2 theta, it's going to be 2 cosine squared. Two cosine squared theta minus 1. So where am I? Where am I in this one? 2 cosine. Oh, that is the one. Okay, double angle. 2 cosine squared minus 1. Okay. So if you plot that in here, 2 cosine squared theta minus 1 minus 5 cosine theta plus 3 equals 0. Okay. What can you do? Oh yeah, 2 cosine squared theta minus 5 cosine theta plus 2. And then let's see. Oh wow, yeah, this is a difficult one. So I think you have to. Is it plus? It is plus. What am I doing with this minus? It's plus. I think you have to complete the square. Yeah, these are really weird ones. So cosine squared. What did you end up doing with this one? Plus cosine theta.
For this one, I ended up switching cosine 2 theta into 2 cosine squared theta minus 1.
But then this 5 cosine, what did you do with this 5 cosine?
I kept it, and then like that equals, then that'll be a quadratic formula.
Oh, I see. That's what you did? Oh, yeah, you could do it that way as well. Yeah, you could either do it that way. I mean, I guess the other way is you could split it. That's method 2. But then the method 2 way is you don't have to do the quadratic formula. But what was your answer? What was your answer for this one?
It's 24, 2 pi over 3 and 4 pi over 3.
Over 3 and 4 pi over 3. Let's see.
Can you like show a way that you plug it in to make sure it's right?
Oh, you mean the one that you did?
Yeah.
Okay. So that way is, so you have A, B, and then C, right? B5. It's been a long time since I did this on 2, 5, and 2. And then so the theta is gonna, or cosine theta rather, is gonna be minus B, right? Plus or minus B squared of B squared minus 4 AC.
Oh my gosh.
2. Do you remember that one, right? You remember?
Yeah, I do remember that.
And then this cosine theta, whatever is being, because it can't be theta. It's not theta. It's cosine theta, right? And then after you plug it in, you have to solve for the theta. That's like the trick here. So minus 5 plus or minus 25 minus 4, 2 and 2, and then 2 times 2. And so just make sure you have the cosine theta. That's always the thing that people forget. What's minus the this is going to be 8 plus 25 minus 16. So that's 9. So negative 5 plus or minus 9. 4, this is 3. So minus 5 plus or minus 3 divided by 4 cosine theta. So cosine theta, let's see, negative 5 plus 3. Negative, so that's going to be negative 2. So negative 2 or 4, negative 1/2 cosine theta, negative 1/2. The other one would be positive 1/2. Plus 3, yeah, positive 1/2. Positive 1/2. Yeah, did you do this?
I didn't use that, but
Okay, and then so you just did a calculator for the quadratic. So when you did that one, and then so you should get the same number. So cosine, when is cosine theta equals negative 1/2? I think it's 2 pi over 3, right?
Okay, yeah, 2 pi over 3.
Yeah, I mean, I guess we'll just skip to it. I don't want to do that in a circle. And then the other one is.
I got for the whole thing. I got 4 pi over 3. So
let's see. Okay, let's just do this one. I mean, cosine this one 4 pi over 3. You got 4 pi over 3.
Yeah, for the final those two for the final answer.
Okay, let me just do the actual thing. So you have this is 60. So that's 60 here. So that should be root 3. And then that's going to be cosine, so 1, 2, and negative. So it seems like it's 2 pi over 3. And the other one here, let's see. So the other one is 1/2. I think it's just And you say that is cosine. So this is going to be root 3, then 1, and then 2. So isn't it pi over 3?
Yeah, but the answer to the thing, because I did it where you like found out what it is times each other, right? Where you found like square, whatever it's called, I don't know. And then I got 2 cosine plus 1 and cosine plus 2 equals 0. So then cosine minus, so like I got cosine theta equals -2.
Okay. Cosine theta equals -2. Okay.
And cosine theta equals -1/2. And you get, that's why, because you get 2 for 1/2 for -1/2.
Yeah, exactly.
It can be 2 pi over 4 and 4 pi over 3. I was confused for a second. Okay, but I got it.
Okay, good.
Okay.
But this way is if you ever did it, this is how you do it. Like it could be sine or it could be cosine. So I think this is an easier way of doing it actually, because like the other way. Do you know if you didn't remember this the other way? Do you know how to do it the other way?
What do you mean the other way? Like
the other way, you have to split your the 5. So the 5 you have to split it in half, not in half, but 4 and 1. And then like after you split it in 4 and 1, then you have to complete this. I think that's the term. Cosine and then it's not complicated, but the math that you do in the end I think is easier. Maybe, I don't know. I mean, it's the same thing. And then like plus 1 cosine. Do you remember doing this? Cosine, not like this way, but then in algebra when you had to like complete and find a way, you have to split the middle here so that you can actually do the factoring. So it's like cosine theta plus 1, cosine theta plus 2. And then here you go. You have 2 things being multiplied, so you can technically get the same answer. So cosine theta equals -2. But this one is a little cosine -1/2. So you threw away this guy. And then you got kind of like a similar one. So yeah, what I would do is just do it the quadratic way, because then you won't really remember doing it this way. Okay. Cool. Is there another one that you want done?
Not really. That's like all I really had questions on.
Okay. So your exam is tomorrow, right?
Yeah.
Yeah. How did you? So you did practice, like you did all of them. Did you make sure to do all the problems that she gave you?
Yes. Sadly.
Okay. Yeah. No, this one is a little. But I think that. Oh, I'm not gonna say anything. But like, it seems like you get like the sum difference one, and then the half angle.
Yeah.
Like, and then like just do a bunch of like. There's a lot of problems that you guys did. Just do a bunch of these like solving trig equations. And then make sure not to panic, like, just always you have a calculator though. Like you guys can use a calculator like for all of them, or
Yeah.
Oh, you can use a calculator.
Yeah.
Okay, so that makes it easy. Easy then.
How do you can like just check it on the calculator, right?
Yeah, like the one thing is after you get a theta, check cosine or sine, whatever, like plug in your theta into like the actual equation, the equality, if it's solving a trig equation, and if they equal, then that's the theta you have. Like actually do the math and then plug in the theta afterwards to check. Yeah. And you already know rad. Make sure it's rad and degrees. Most of the time you're going to be using rad. So yeah, make sure maybe you set up your calculator for rad already, because then I know some people, they always forget, and then like everything is wrong.
Nice.
Can you imagine? Everything can be wrong if you by that mistake.
I would just die, to be honest.
Okay, cool. All right. Yeah, I think you're gonna do great. Just let me know. So
Okay.
And then I'll ask your professor again for what are you guys gonna do after this one?
I'm not sure actually. I'm not sure what we're doing.
You guys already did like cosine stuff. I don't know what else is it. Okay, I'll ask her and then see. I'll send you what she gives me.
Okay.
Cool. All right.
Thank you. Bye.
See ya.